Hey guys, are you ready for the exams? No. Why not? This is how I know that how much you understand my course. And this is a good one. Okay guys, as you know, I just already posted the date from the week one, session one, that we will have the exam one on Thursday. You know this one from 4 weeks ago. But I want to remind you, the exam will be on Thursday. Okay? It's my birthday. Okay? And please, if you want to just make me happy, get a good grade. Okay? This is the best gift for me on this day. During the class time, we will have the exam. Okay? And attending the midterm is mandatory. If, for example, the class will go to the virtually, it happens. Michigan weather also is unpredictable. We will postpone it, but we will have the exam on Thursday. Please bring your own calculator for the exam. You cannot use your phone, you cannot use your computer, tablet, get the calculator from your friend or your neighbor. Okay? If you do not bring it, you have to just use your hand for the calculation. Okay? The exam will be closed book and closed note. I will provide the equation sheet. I posted the equation sheet in the week 4. Now you can see that the equation sheet is provided. Same equation sheet. I will print. Do not print it. Okay? And also, the exam will be cover the material until today, just whatever I teach. And also, we will have the review session today. It will cover all materials. Okay? For the exam, what should I study? Please study first my notes, whatever I solve in the classroom. Second one, homework. I posted the homework solution. The homework 3 solution also is tonight. After the midnight, I will post the solution for the homework 3. For some of you, just uploaded the homework 3, and also you need a solution sooner than midnight. Shoot me an email. I can send you the homework solution if you want it before the midnight. If you just can wait, please wait. And also, from last week, I just posted some practical examples in the Blackboard. You saw lots of examples I posted in the Blackboard. If you go to your Blackboard, you will see practical examples on the week 2 or week 1. Practical examples, just I posted some of examples. This is good for you, and also familiar yourself with the content of the course. Okay? Also, please study those ones. Okay? And we will have the review session today, second part of the class. If you have any questions for the homework, for the lecture I did it, or anywhere, stop by my desk. I can answer all of your questions. 1 hour, you have a good opportunity. If you do not understand one content, one problem, anything from the homework, from my lecture notes, from the solutions, whatever, stop by my desk. Okay? I can answer all of your questions. Any questions? Any questions? No questions? Did you study for the exam? Do you have exams in this week? Other exams? Yes.
How many questions are going to be on the exam?
5. First question, you will see the format that I will provide for you for the review sessions. Same format I will give you for the exam. First question is the multiple choice question. The remaining questions are you have to solve. And it will cover all of the content of the course. Projectile motion, rectilinear motion, the curvilinear motion in XY coordinate system, curvilinear motion in normal and tangential. Yes?
75 questions, would it be like a time limit, like 30 minutes, an hour?
This is for whole class time. I wanted to limit it, but some of the students are asked, answer the questions in 30 minutes. Some of them needs more time. I cannot limit it, and also students just not saying. That's the reason it's for whole class time. You can take 2 hours. You can give me your paper after starting the exam, 1 minute after the start of the exam. It's up to you. Other questions? No? Okay. Can I move to next slide? Oh. Okay. Just review of previous lecture. Then I want to solve more examples today. Then we will have the review session that you can read, study, review contents, and everything. We started to talk about normal and tangential coordinates for a curvilinear motion. Tangential axis, it is this axis that is tangent to the path. And normal axis, it is perpendicular to the tangent axis. It's toward to the center of the curvature. Also, we use different unit vectors along tangential and normal. Unit vectors, the magnitude of them are 1, and they are in the direction of tangential and normal coordinate system. The radius of the curvature I show you, this is rho, that if I just draw a line from center of the curvature, that this line is approximately, just if I draw the tangent line at this point, this line is perpendicular to the tangent line. This line shows the radius of the curvature. And also, we can find the ds. S is the distance, how much particle moves along a curve. And ds is the differential of the s, or a small amount of the s, if the particle moves from the p to the p prime. This amount of the curve, or this one, is called ds. We can find it using this relation, rho d beta. D beta is the angle between if the particle moves from p to the p prime. This angle, it is called d beta or d alpha, whatever you like. Then we found the velocity in the normal and tangential coordinate system. Velocity, it is tangent to the path, and the magnitude of the velocity, it can be found from s dot. S dot is the derivative of the s with respect to time. S, again, is measured along the curve, and when this particle moves along the curve, s will be increased. Okay? And the change of this s with respect to time is the v, or the magnitude of the velocity, or called speed. Then I want to find the acceleration. Acceleration is the derivative of the velocity with respect to time. Now, if I plug in this one into this equation and take the derivative, I can find the acceleration, or the components of the acceleration, along normal and tangential directions. This slide shows that how we can find the components of the acceleration in normal and tangential coordinate system. Just I skip that one. This is the proof, but these are the final results. What it means, the acceleration has two components. One along tangential called tangential acceleration. Okay? This is normal acceleration. It is perpendicular to the tangential. The resultant of these two acceleration is A, or total acceleration. AT, or tangential acceleration, is the v dot, derivative of velocity with respect to time. The normal acceleration is the v squared divided by rho. Just for a car, it's moving along a curved path. Here is that car. This car has one acceleration tangential. This is that car. And one acceleration along a normal. If you know the change of the velocity with respect to time is tangential acceleration. If you know the speed, you have to square the speed divided by rho. This is the normal acceleration. This acceleration causes forces that if you just move and also drive your car with speed along a kind of a circular path or a curved path, you will feel some force that apply to you and make you just toward to the center of the curve. This is because of this acceleration. If there is no curve, this radius of the curvature will be infinite. Just I will explain later on next. Then, this type of acceleration is because of the change in the magnitude of velocity. This acceleration will be changed in the direction of the velocity. Okay? Again, here I can write this acceleration in terms of two acceleration along normal and tangential. These are unit vectors along a normal and tangential direction. AT is the tangential acceleration, and also we can use this formula. This formula is coming from week 1, session 2. If you remember, ADS equal to VDV. Now instead of A, I just substitute AT. If there's no time in the problem, you can find and relate A with the S and also velocity using this equation. That is one of the kind of next problem I will solve. Any questions? Okay. Also, this slide explains about the tangential component of the acceleration. Exactly what I mentioned. This tangential component of the acceleration, it depends and with the change of the speed or the magnitude of the acceleration, magnitude of the velocity. Now, some special cases. First one, I just asked you in the previous lecture, but I have to review. If the particle moves along straight path, Which acceleration will be 0? AT or AN? Which one? I just write the formula. If a particle moves along a straight path, which acceleration will be 0? Yes. Why?
Because there's no curvature.
Correct. Because there is no curvature, this acceleration will be 0. The second question, if the particle moves with a constant speed, which acceleration will be 0, AT or AN? Which one? Yes.
AT,
Why?
because it's constant speed, so there's no acceleration.
Correct. The AT will be 0. This acceleration will be 0 because AT is the V dots. When V is constant, the derivative of constant value will be 0. These are some special cases. Also, you remember that I explained about the radius of the curvature. For example, at this portion of the curve, and if this one is the center of the curvature, this portion of the curve has a kind of radius of the curvature. Then for most of the problem, this radius of the curvature is given in the problem. However, if this radius of the curvature is not given to you, how you can calculate the radius of the curvature at different coordinate systems? I will show you the next slide. Any questions? No? Can I move to the next slide? Yes? Okay. For example, this one is a curved path, or this one is a curvilinear motion. If a particle moves on a curved path, it has a curvilinear motion. If the equation of this curve, it is given to you, y as a function of the x. Look, this is xy coordinate system. Right? If you have the function, you can draw the curve easily. Then I want to ask you that what is the radius of the curvature at this point? At x0. To find the radius of the curvature for this point, we need to use this formula. To find the radius of the curvature, we'll use this one. Inside of the brackets, 1 plus the derivative of the y, this function, with respect to x, and this inside of this parenthesis goes to the power of 2, and brackets goes to the power of 3 over 2, divided by absolute value of the second derivative of the y with respect to x squared, and when at what point at x equal to x0. You need to find the radius of the curvature using this equation. If the radius of the curvature is not provided in the problem, you need to find it from this equation. For example, it's a random function. Y equal to 4x squared plus 3x, or plus 3. We want to find the radius of the curvature at x equal to 1. For example, now using this formula, rho equal to inside of the brackets 1 plus inside of the parentheses. To find the derivative of the y with respect to x, it is 8 multiply x to the power of 2. The brackets goes to the power of 3 over 2 divided by the second derivative of the y with respect to x squared. The second derivative of the y with respect to x will be 8. And whole of this one can be found when x is equal to 1. If you put into this equation, just put x1, for example, you can find this one equal to 1 plus 64 to the power of 3 over 2 divided by 8. If you calculate this one, let me calculate. It is, I just missed this. It is 65.5 meters, for example. This is the radius of the curvature at x equal to 1. This curve can be the path of the car that moving along this curve at different points. You want to find the acceleration. For example, at this point, you want to find the normal acceleration. If the speed is given to you, you can square the speed divided by this one. You can find the normal acceleration at x equal to 1. Got it? Any questions? I want to solve, no, just 2 slides and then solve examples. Okay, move to the next slide. Yes? Okay. Now, for one type of the motion, if the particle or rigid body moves along a circular path. Circular path is an example of circular curvilinear motion. But for a circular path or circular motion, the radius of the this kind of motion or this path is constant. Or the radius of the curvature is constant. Now for this type of the motion, if this point represents the particle, there is an acceleration along tangential and normal. And this r is the radius of the circle. And theta is measured from this line, for example. If I draw a vertical line, I can measure the theta that moves the angle that compare and also find the angle of the particle from this point. Now, we want to find the velocity, acceleration, tangential, and normal. These are just familiar and also same as what we found from previous slide, but I want to explain what are they. If you remember, I explained that V, the magnitude of velocity along a tangential acceleration, can be found from S dot. S is measured here. For example, if this one's starting from here, S is measured along the curve. Okay? Now, if I want to relate S with R and theta, how can I relate them? How can I just find the total length of this arc, or S? How can I relate S, R, and theta, or find this portion of the arc length? What type of equation can relate S with R and theta? Please raise your hand. I can see. How can I find the total length of this arc length? Let me help you. S can be found using R theta. Now, to find the velocity, I need to take the derivative of R theta with respect to time. Because R is constant, the radius of circle is constant. This comes out of this parenthesis. It will be equal to R theta dot, or R derivative of theta with respect to time. What does it mean? The speed of a particle that moves along a circular path can be found if you have the radius of the circle and the derivative of theta with respect to time. This expression, derivative of theta with respect to time, is called angular velocity. The unit of the angular velocity, as you can see, it is radian per second. And what is this type of the velocity? It's a velocity of a rotating particles. For example, if you have a blade or turbine blade or any rotating body, some of the blades just moving with high speed. This speed can be measured using theta dots. If the speed is high, it looks like this. If the speed is slow, is that theta dot is slow, or angular velocity is slow. Or one more, in your company, just if you're working on tire companies, they just attach the tire. It's a tire to this electrical motor and rotate the tire. Okay. Now this tire is look like this. Now, for this tire that rotates with this one is angular velocity. If you know the radius of the tire, for example, just a number. The radius of the tire is 0.5 meter. And this tire rotates with the angular velocity of 2 radian per second. I can find at this point, for example, this is the velocity or linear velocity. I can relate this velocity with theta dot and r. How? Using this relation, v or speed or the magnitude of this one. It is r theta dots or 0.5 multiplied by 2. The velocity will be 1 meter per second. At any points on the kind of surface, outer surface of this tire, the velocity will be 1 meter per second. But the direction will be changed. Yes?
Was theta given, or did you calculate theta?
Theta can be measured. For example, at this angle, it is, for example, 120 degrees. At this angle, it is 180 degrees. But the change of this theta with respect to time, it should be given to you. Okay? Any questions? Also, we can find the acceleration. How? The normal acceleration is v squared divided by rho. Just I plug in r theta dot into this equation, and we can find the normal acceleration, this component of the acceleration. And also, if I plug in r theta dot into this equation, we can find that the tangential acceleration for this acceleration, it will be equal to r multiplied by theta double dot. One question. Can somebody guess what theta double dot is called? Yes?
Angular acceleration.
Angular acceleration. Theta double dot, it is called angular acceleration. The unit of this one, it is radian per second squared. Anytime for a rotating body or rotating particle, we can relate normal and tangential acceleration if we have r or velocity or speed, and the angular velocity and angular acceleration. And maybe we will reach on week 8 when I start to talk about the rotation of the rigid body. Also, I will talk about the angular velocity and angular acceleration again. Okay. Any question? No. This slide just is about what's the angular velocity and angular acceleration. This is for your reference. What are their units in SI, in US units, and what are the units of angular acceleration in SI and US units? And also, the theta is always just work with the radians, not degree. If the degree is given to you, just convert it to the radians. You know the relation. Pi is 180 degrees. 1 degree, it is pi over 180 degrees. Okay. Any questions? No. Let's solve examples. This is a slide for your reference. If you want to solve examples, problems, you can refer to this slide for the formula. Just I put in the captured from the book. Okay. Now, scan the sparkle. This is the review what I explained here. I want to see how much you just learned from today. Answer these two simple questions. Everybody, please participate. I provided equations for each question. Also, I show you what is the normal and tangential. Please answer these two questions. They are very easy questions. Did you answer the questions? Who needs more time? Raise your hand, please. Okay. Can you show the results? Yes, true. Yes. Let's see how you answer the questions. Second one, half of the class answer incorrect. Okay. Now, let me answer then. First question was the easy, just most of you answered correctly. When the particle moves with a constant speed, I already answered this one. When v is constant, this one is the derivative of v with respect to time, and means that this will be 0. C. Easy question. Second question, the normal component of the acceleration is a sub n. Now, how can we can find it? I think most of you answered this one. This and this is incorrect. I eliminated the incorrect options. C is magnitude of velocity is incorrect, and also the direction of total acceleration also is incorrect too. Now, between A and B, how we can select the correct answer? You will see that the tangential acceleration is the change of the v, or the magnitude of velocity. That was the easy one. If you do not know the A and what is related to, the AT is the change with the v dot. What is the v? V is the magnitude of velocity received. It means that A is the definition for the AT, not AN, or normal acceleration. This one, this option is for the AT. This one, is the correct answer is for AN. Got it? Okay. Can I move to the next slide? Now, some examples. The car travels along the road with a speed of v equal to 2s. Means that the speed is a function of s. Now, where s is in meter and rho, radius of the curvature, it is 50 meter, we want to find the magnitude of the car's acceleration at s equal to 10 meter. At this point, this is the car moving along a curved path. The tangential and normal axis, they are drawn here. When s equal to 10 meter, the speed of the car, it is 20 meter per second. Means that this car, at this point, this is the velocity. The magnitude of this one is 20, and it is along the tangential direction. This is the v vector. This one is the magnitude. Also, this car has an acceleration in tangential and normal directions. Last question of the review session, it will ask you to relate AT with AN and what are their correct directions. Also, the resultant of this two acceleration, it will be this total acceleration. A, the resultant of the AN and AT. This A, the magnitude of the acceleration. It can be found from this formula, AT squared plus AN squared. Now, let's go to find. To find this one, I need to find this and this one. Tangential acceleration and normal acceleration. Normal acceleration can be found from this equation. V squared divided by rho. We have the V 20. The radius of the curvature is 50. Normal acceleration it is 8 meter per second squared. Easy part. But I want to find the tangential acceleration. Tangential acceleration will be v dots, or the derivative of velocity or v, speed, with respect to time. Now, one question. V, as you can see from the problem, is a function of the s, not function of the time. My question is from you. How can I find this derivative? Is it 0? How can I find this derivative? Is it 0? Is it 0? No. Then how can I find this derivative? Yes. You're close. How can I find this derivative? How? This derivative can be found from chain rule. Derivative of velocity with respect to s multiplied by derivative of the s with respect to time. Or if you do not know the chain rule, just add ds to the numerator and denominator. Okay? Now, how much is the derivative of v with respect to s? How much? 2. Then, what is this term is called? What is this term is called? Derivative of s with respect to time. Can you please say louder? What is this derivative is called? What? Sorry, I cannot hear. What is this derivative is called? Derivative of s with respect to time. Velocity. Velocity. Now we have derivative of v with respect to s. 2. Let me erase my circles. Then 2. How much is the velocity or speed? 20. It is 40 meters per second squared. Then I plug in into this equation 8 squared plus 40 squared. This will be, I think, 40.8 meter per second squared. This will be the answer. Got it? Similar to this problem, I will give you for the review question number 5. Any questions? No? Can I move to the next slide? Yes. Second example, the car starts from rest at s equal to 0, increases in its speed at at equal 4 meters per second squared. We want to find that how much does it take that the magnitude of the acceleration become 20 meters per second squared, and what will be the position s? For this problem, you will see it's a curvilinear motion, and we want to use a tangential and normal coordinate system. At this point, if I draw a line that is tangent to this path, this one is a tangential axis. Normal axis will be perpendicular to the tangent one toward to the center of the curvature. This is the center of the curvature. This is the normal one. At this point, at this moment, the tangential component of the acceleration, the red one, it is given to you 4 meters per second squared. And we know the magnitude of the acceleration, the total acceleration, this one. This is the resultant acceleration. The magnitude of this one, this vector, it is 20 meters per second squared. Now, from this moment, starting from here, origin is somewhere in here. If we measure this distance along the curve, it is S. We are looking for S, and also how long does it take that magnitude of acceleration becomes 20. For this problem, they are given starting from rest, V0 will be 0 meters per second. Starting from S0, or S0 will be 0. Tangential acceleration is 4 meters per second squared. The magnitude of the acceleration, it is 20 meters per second squared. We are looking for to find S and time. Now, my solution, I will use normal and tangential coordinate. You know, the magnitude of acceleration can be found from this at squared plus an squared. If I substitute into here, we have the magnitude 20, tangential acceleration 4. We do not have the normal acceleration, but we can find it. From this, we can find the normal. How much? (400 minus 16), and the square root of this will be 19.6 meter per second squared. Now we have the normal acceleration. I can find the velocity. How? Normal acceleration, it is v squared divided by rho, or 19.6 equal to v squared. Radius of the curvature, it is given 40. We can find the velocity. 19.6 multiplied by 40, and the square root of this, it is 28. Velocity will be 28 meters per second. Now I have the velocity. How can I find the time? Can you tell me how can I find the time if I have the velocity and acceleration? If the velocity is given, also you have the acceleration. How do you find the time? Yes.
The velocity, the initial velocity plus acceleration times.
Correct. Yes. The acceleration is given to you. It's constant. We have the velocity. Then, can I move to the next slide? Yes. Look, this one is given. Just I capture it. This part. And I go to next slide. Let's just let me see. Okay, now at this moment, the S10 acceleration is 4 meter per second squared. Also, we found the speed 28 meter per second. Then, if the acceleration is constant, we can use this equation v equal to v0 plus ac multiplied time. We have the velocity, initial velocity or speed is 0 plus acceleration is 4 multiplied by time. From this, we can find the time 7 seconds. Also, we want to find S. S, it is measured along this curve. If you remember this formula, S equal to S0 plus V0t plus 1 over 2 AC t squared. S0 is 0. It's mentioned in the question. V0 also 0, starting from rest. Plus 1 over 2, acceleration is 4. T squared that we found 7. Now, if you calculate this one, it will be 2 multiplied by 49. S will be 98 meter. This is the answer. This one will be the answer too. Any questions? No question? You are very good students. Do not ask me questions. Yes?
Is rho the same thing as the radius?
Rho is same as radius when the particle moves along the circular path. Only. Yes?
For the distance equation, would we always use the tangential acceleration?
Yes, because the tangential one is because of the change of the velocity with the magnitude of this. Good questions. I motivated you to ask questions. Okay, if you do not have questions, let's have 5 minutes break. Come back 2:30. We will start the review session. already. Okay, let's start the second part of the class. The review session it has 5 questions. It's a participation in the class. Please answer those questions. You can use your note, the homework solution, anything. Also, you can work with your friend or your neighbor. Okay, but please do not copy. For example, play it and then at the end of the session just copying from them. I will circulate. Please answer all of the questions. Let me know if you have any questions. And you have to upload your answer at the end of class time. Okay? You have to upload. I do not need the copy. You have to upload whatever you solve until end of the class time in the Blackboard. Okay? This is a class participation. Yes. If you can use your phone, I uploaded vector equations. Before. Yeah, I upload. I will show you here too for some of you. Any question, guys? I'm here. Please ask me. If you need any help for the question, also let me know. I can help you. I understand. You can do it. Let me see. I'm worried that
What's vertical? What's constant? Those are different. Sir, those are having a stroke. Okay. That checks out. They always do this. S is equal to this minus this plus that. Velocity is the derivative of that.
Yes.
2t minus 6. A is equal to 2.
Because Jack.
He's not here.
He has pneumonia. He has a valid reason to
I
have
know,
me here.
but kind of doctor knows because it's a class participation. I just want to know that who is available, who's not available. I just send me an email from him. I'm not sure that who sending.
I honestly don't know what car that is.
It's not from here, I can tell.
To be honest,
Like a really 90s Focus that somehow
no,
made.
it's the wrong shape. This is
For Focus or Fiesta.
If your sister send me notes,
Engine
I will
bezels
provide
will
them, and I will send the kind of
So I think it's a
deadlines for
Dingo.
them.
Actually, don't know what the dingo is.
The dingo? It's awful. It has horrible headlights too.
All 32 students have to prepare for all of it.
What?
Some of them have
Bingo.
classes, some of them not. Some of them not. How can it work?
That's not.
But if you can send me an email, and also those things, which I understand, I don't know, I'm not sure about that. Yeah, I received one from one other CSP. I just mentioned it to all of them. If you can provide me documents,
Dingo.
I can send you this one and exchange it.
That thing right there.
It's 4-door, not 2-door.
It's a 4-door?
That's 4-door.
Really?
Yes.
Those are not what I was thinking. What is a photograph? I have no idea what the hell that is.
Photograph is the graph that showed the acceleration. I just posted the solution.
Oh,
posted
those-
the video.
Those like
Yeah.
sinusoidal
Yeah.
things.
So like,
Look, if this is a kind of graph, velocity, and velocity.
oh yeah.
If I draw this, and this one, and if I connect this two one, this graph is called photograph. And the acceleration will be tangent to the photograph.
The cool thing is there's an answer to that. Right? I think that's what you're trying.
He's asking
Yeah.
for velocity, not acceleration, though.
Yeah, but it would be,
It's still the same thing.
Perpendicular.
Instantaneous
no,
is at
velocity
a
would be
point.
this one is correct. No, tangent. The velocity is tangent. Path.
Yeah. Oh, I think you said tangent to it. What? Okay,
No,
hold on.
this is-
Hold on.
Okay, so this is the path. This is the path. You have the velocity along here.
It's instantaneous, but the path,
Yeah.
the entire path doesn't matter.
No, because the velocity goes along the path. The
Oh, that, wait, just the up arrows, the photographs?
the
Oh.
photograph is the one that goes
This
here.
graph is called.
Okay, so
I'm
those
so confused.
are those three vectors.
Look, this is a general curvilinear motion.
Okay.
At any point, I can draw the velocity
Yes.
that is tangent to the path.
Okay.
Correct?
Yes.
Now, if from one point I draw the velocity vectors, same direction, this one, same magnitude, same direction from this one.
Okay.
This one, same magnitude, same direction.
So it's like
And is that are
You're
those
just
three
taking-
velocities?
For example, this is velocity.
you add
one.
them together?
Yeah. Look, this is velocity 2.
Okay, so those are
This
velocities.
is velocity 3.
And so
Okay.
this is like total velocity over
No,
the
no,
path?
this is exactly same as this one.
Yeah.
The
But like-
same magnitude, same direction.
What is it showing? Why would you put them all together?
Yeah. To put all of them, and there is some point at the
When
end
you
of
make
this
the
one.
path?
Yeah, I make the pass and make a graph using end of this.
Okay.
This graph is called photograph.
Okay.
That acceleration, it is tangent to the photograph.
Okay. All right.
Sure.
So this
So
that
does
that
that-
path would be the acceleration.
Yes.
So does that mean then that the velocity is perpendicular to the path?
No. Why? Why?
This is exactly
Perpendicular?
just
Velocity is
Never.
Oh,
per-
oh, never mind, never mind.
Never perpendicular. Okay.
this for this option just I
Okay. I didn't, so the photograph is to add the velocities together to get the acceleration.
Yeah.
And that's the photograph. Does that work for position? No. Why would it work for position? Do not answer. That's completely a
you
bad.
answer your question.
Yeah. Okay. Cool. That makes okay. That's cool. Thank you. Okay, no, that's a good thing.
Got it?
Yep.
Thank you.
No, you add velocities together.
Correct.
No. Just take directions, right? From the 1.8. Sure. How it works.
I like it. Oh, that's actually. Yeah, so I would look at that. Potential so we do all you got. So there are two. Obviously, all average lives there. Average
There's a problem here, and the average velocity is the time we only have 6.
We don't have a. Okay, can you make sure that that's specified in policy?
Which makes.
It's hard.
Just draw. I just draw like this. Kind of think of like what. Yes, that's. So I guess and then add the initial plus that point absolute value and then plus. Well, just like a wording question. Oh, I see. Like, does it just mean like the college? Yeah, I know. I read
Yeah,
that
just
wrong.
normal.
Okay. So how does directions come into the equation?
The velocity is a vector.
Yeah.
Vector, what is it? Vector has if the magnitude change, the edge charge solution is going to change. If the direction of velocity change, the normalized solution will change. For example, if the kind of because what is triggered is the direction of the velocity is not going to change. The direction of acceleration always. So he is 6. So 0. 6 times 3 is minus 3 squared is 9. Minus. Minus 6. 6 minus 79 minus 5.
It's traveling. It is sometimes. Don't matter. I don't understand how your brain works. It makes sense.
9 minus 5.
Yeah. From 0 to 6.
Maybe next time just be smaller.
They'll give equations to tell you what happens.
Oh. No, I understand. Yeah.
I think you're incorrect. What happens?
Well,
What happens?
Oh, yeah.
We know it. I think you get one. Negative. That means negative. Yeah, that makes sense, okay. Negative, think about so it starts at 5 and then it goes back to -4 and then it goes back to 5. So that's yeah. That's for this strap. Because displacement is 0. What happens? Is that what you got?
Read it.
Where's the change?
I'm gonna. Because on the test, if I guys are something wrong.
So I originally thought that I would find the position and then plug in like the X, Y, Z coordinates, but I realized that there is no X, Y, Z coordinates in the back end, so I'm kind of stumped as to how I proceed.
Velocity is the derivative of s with respect to find the s. Yes, will be ddt. To find the s, you need to take the integral. If you put the velocity into here, you have to integrate of this one.
Oh, okay. I see. I see now. Thank you.
Good question. You say determine the displacement of the particle. Do you mean like the magnitude of displacement or just this? Because there's always others. This.
Displacement means that S3 minus S1.
This. But for the but once we have that, we get this right, and then
Just
Where is it at?
subtract this by this and find the displacement in terms of ING.
yeah, but we don't have to. Oh, we don't have to.
Down on us.
Our displacement. Sometimes you use your they're not displacement, but like it's these are ours is glowing. It's DS over each.
Find the acceleration.
That's what I was
I know that one main thing to do at this time is try to figure out find the time.
Yes.
Normally, from the equations, when we do this, we could just move one of these outside.
Yes.
Here, not so much the case.
Yeah, let me see. Look, this one is correct. Okay, I do not know the numbers, but look at the overall adjustment. Also, this is correct. This one is correct. Let me just check. Now, one option that you can find the time based on the d, for example, d cosine 30 over 30, something 64, plug in into here and find the d, or vice versa of this one. Find the d versus of the time and put it into here. I think that this one is much easier. Okay, this one. If you put in here, you have time, time, and time, and it is a polynomial. You can find the time first.
That case, and after that, right?
You can bring this one to the right, and we have something t squared, something t, and you can find the time. Do you need my help?
I'm still not entirely sure.
Okay, let me help you.
I don't
Look,
know what.
okay, so this one, I bring this one to the right, this to the right. This will be 0, 0 plus. This one is 2571 t minus 1 over 2, 32.2 t squared. This is this one. Minus 30.64 t divided by cosine 10 sine 10 multiplied by time. Okay? Now you have this and this, adding this together, you have this, find the time. It's a polynomial.
Okay. So
Got it? Yes.
For this, am I inventing stuff?
No, it's okay.
Is good?
Yeah.
Okay.
That's what I'm looking for.
Okay,
You
so then that
understand
will
that
give us a.
this 10 cosine 10 is 80, 10 sine 10 is 80. That's it.
Okay.
Then putting those formula and just solving the classroom, you can find a find rho or something.
Okay, perfect. Thank you so much.
For this one, you want to think of the how the origin is going to be. This should be now. What'd you guys do?
I would have done. Maybe that's what here. I used so so they are going on 3 years. But if you were to do it real fast, then just 3. Got 30.
That's gonna be about.
I think I'm gonna. So I don't know. That's the brilliant part about that. Yeah.
I kind of did that. I actually did it. Yeah.
Oh, that's the IJ. Yeah, EV section. So pretty high. That's like I don't know why like X and Y. So like like the there's one way. Yeah, that's Oh my God! Yeah, exactly. All that is that's the change. That's the difference.
We were talking. Yeah, because I saw that. Yeah, the agency was talking. Or like. Yeah.
Yeah.
If it was actually like that, then, you know,
So I know that but I think this guy's terrible. Yes.
I have done it. Oh. It's just, no, it's just Okay, so like, you know what I mean?
Yeah. It's out of context.
Yeah, that's why, that's why.
I don't understand. This is right.
Oh.
So I took the next well, yeah, but this is yeah, but this is just like oh yeah, yeah, that's yeah, I don't know. I don't know. I was gonna leave it flat. It's the actual test. First of all, you have I know, I was. No worries. I like to always. Yeah. Yeah, we kept 300. Oh, that's. Oh, yeah. It's actually very. Or something. No, we're still stuck.
Yeah, that's, I was getting. Okay.
You're telling me, bro.
I mean, that was the I got that. I think, I'm sure I also got Dropbox. 30.
This time I didn't know why.
I'm still pretty, I got both positions.
No. Oh, yeah, actually, that is.
This is the equation.
Oh, first of all.
Yes.
So I'm a little confused.
Now, displacement is the best.
Yes.
Or now, find the R.
So you pretty much are saying.
Oh, so it's hard.
That's one. Why? Because this integral has.
No, I know, right. I would never. I don't think. Well, since we're running. My gallery is.
Okay, yeah.
You are putting it on chat.
Yes.
Okay, guys, one more question. Before we just, some of you are finishing and also some of you leaving the classroom. I will answer those questions after I explain. Please, guys, pay attention one moment. Please, whatever do until now and upload it in the Blackboard. Please, all of you. How many questions you solve, it doesn't matter, but whatever you solve, please upload in the Blackboard. Then I will extend it until tonight. Okay, solve it in the home and send the second attempt if you haven't solved the problem completely. Okay, please answer all of the questions. Similar question or one of these questions might become for the exam. Okay. Thank you very much. Just please upload before you leave the classroom. Okay, guys? Yes.
Oh, really? Never mind. Oh. That's fucking weird. I close my eyes at night, I'll turn kids how many kids are in the way that keeps us on? The real questions are those that are hidden Yes.
Let your brother know. If he can do
Thank you.
and brother.
Yes.
Okay, so with this one, I turned in what I have so far. I didn't turn this one in.
It's okay. Whatever you did it, just upload it.
But with this one, so now once I get to here, so cosine of 40, I got as
Yeah,
that
look,
number.
D in here, you should just put D cosine 10. Here, you should put D sine 10. You have two equations to know. Solve those equations.
So
D cosine 10 is equal to 0, 40, something, like this.
yeah, this is cosine of 40.
Yeah, cosine 40 multiply time.
V0.
Yeah,
Oh,
this is V0x. This is V01.
Okay, so that's 40. That's why it's 40 for the x direction. And then is it 0 in the y direction?
Yeah, exactly.
I like them because.
So
No, I just downloaded it actually. I just emailed it. Like, I run
This
my
one gets hard to sit through sometimes.
So what's the real thing?
So V0 in the x direction is 40. V0 in the y direction is just 0.
Sad is really what.
Why?
Right there.
Look.
That's not in X direction.
Yeah, I mean,
Did he say that?
Yes.
He did?
He said V0x is 40, V0y is 0.
Huh?
Okay, I was hoping you'd say.
Why? Like, why is velocity X 40?
It's not 40, it's 40 cosine 40.
Yeah, that's not right.
No, I didn't write this.
Okay.
He wrote it.
Josiah, I was like,
I didn't write it.
Okay, my question was
This one is 40 cosine 40.
Yeah, okay, that makes sense. That's why I was, okay. Can you?
This one is 40 sine 40.
Can you? So right now I have this and this.
Yeah.
Our variables are only t.
No.
No.
D
Oh,
cosine 10. This one is D sine 10.
Okay.
Now your variable is D. This is equation 1. This is equation number 2.
Yeah. So any third equation?
And this one is 1 over 2. Half of this.
Oh, there is one half there.
Yeah. From this and this, 2 equation, 2 unknown.
Okay. So does this work?
I'm not sure the numbers, but I think that this is kind of
How do you solve for 2?
Sorry, I have to just
Oh, there is
yeah,
a question.
other-